Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Peace and blessings upon you all. Dear students, here we are doing a factorial program, okay? And a factorial program in 886 assembly language. But we know if we have factorial program, that means if, for example, we have number 5, so factorial of 5 is 5 into 1 lesser than it, that is 4, lesser than 1, 3, into 2 into 1. That is 5 into 4 is 20, 20 into 3 is 60, into 2 is 120, into 1 is 120. So answer is 5 factorial is equal to 120. So that means any number we have to minus it with 1 and multiply it with itself. Then whatever the answer comes of these two, we have to multiply it with 1 lesser than this. Then whatever the answer comes between these two, 20 into 3, that is 60, okay, multiply it 1 lesser than 3, that is 2, and then up to 1, and that's it. So how we do this in assembly language? Okay, let's try to understand it. Let me clear the clutter first. And so what are we doing here is we have already learned how to actually get the number from the keyboard. It could be the 1 digit, 2 digit, or the DW or DB if you have 2 digit, or it could be 4 digits if you have a DW, the word size, that is 16-bit. We have already done the 16-bit number taking and output. We have done how to output 16-bit number and 8-bit number, 2-digit numbers, or any many digit numbers. We have done that. So you will do it off your own. I'm just putting up, I'm concentrating only on a factorial function here. So what I'm doing here is I'm creating a DW. So you can have a DB or whatever the numbers you have here. It could be the single digit, 2 digit, 4 digit, whatever. So I'm taking just I'm taking a DW, that is the word size, that's 16-bit size data type, and I'm getting a single digit number, hexadecimal number, so 05H. So that means 5. Typically I'm taking 5 in my DW, the num in my num, which is of data type DW. Now we may have the print string macro. We already know it, how to print the strings, because you may have a lot of strings to print. That will be your the home task. You will do it off your own because we have done it many times now. I concentrate only on the factorial. Rest you will do it off your own because we have already done all those things. Now in the code, what I'm doing is we got a main proc, okay, we got a boilerplate code. Then you will print those messages and scan the number from the keyboard and all those things, whatever you want to write it here. And in my case here, I'm just putting up the number in my DW. So cutting the crap because you already know all those things. We have done it many times now. Then I call the factorial and I jump to the factorial program where I will do my things. Okay, so this is my factorial program. So in your case, you will have the scan proc, okay, and you can have the print dl proc to print each and every digit of an answer. Okay, you will fill them up. You will fill this code here, you will fill this code here, you will do it of your own, and then accordingly adjust in the main proc how to print all those digits, how many digits we have. Okay, but I'm just concentrating on a factorial, simple, so that it will be very fast and quick. So what I'm doing is in my num right now, what is in my num firstly? So in my num, I have the 5, sorry, in my num there is a 5, right? One second, let me clear this screen draw. So in my num, I have initially 5. So num is having 5 in it. So I am putting that 5 into the AX register. You can do it many ways. This is one of the way. I am putting the num into the AX register. That means num is also 5. Now AX is also 5. Right, both of them are 5 5, and I'm also putting into the CX the num. So CX is also having 5 in it, right? So I have CX5, AX5, and num 5. All three values are 5. Now I decrement the CX, so the CX becomes 4. Now CX is 4. Okay. Now what I do is here is I decrement num. I make num as 4. Now num has become 4. Okay. It was initially 5, now it has become 4. Now this was 5, it has become also 4. Okay, so this is what I'm doing. I'm doing the here the decrement cx. Now I decrement the num, I cx and num, both of them decremented here. Then mul num, what the mul num means? Mul num means whatever is in al, do al into num. So whatever is in num, multiply it with al, because what I want to do, if it is a 4, I want to multiply 5 with 4, then with 3, then with 2. Okay, and then last with the end with the 1, or I could skip this one. So that means if this is 5, this should be multiplied with 4. This is I'm trying to do. I am saying in my num, what is in num? That is 4. So multiply 4 with whatever is in ax or al. Okay, right, in this case, because the thing is in al. So what is in al? Because I dropped 5 into the ax, so al will be having 5. Okay, so that means typically it means this first time the mul num means 5 into 4, because 4 is into the num and 5 is in the ax register. So this time, first time around, it is in the x is 5 and num is 4, because I decremented num, that is 4. Okay, now I decrement cx, the cx becomes 3. Okay, and I am seeing jump not 0 if cx is not 0, because jump after this statement, that means if cx is not 0, is cx 0? No, it is 3. So I should jump to again, so I go jump here to the again, and I decrement again the num. Now num will become 3, and I mul num. So what is in the num? In the ax, now ax is actually having 5 into 4, that is 20 in it. So in ax I am having 20 in it now. Okay, so mul num means whatever is in ax, that is 20, into the what is in the num is having 3, so 20 into 3. So this thing happens, 20 into 3. Now after this I decrement cx again, it becomes 2. And is it 0? No, the jump again, decrement num, it becomes 2, because I want to now multiply 2 with whatever is in ax. In ax now I have 5 into 4 into 3, right? That is 60. Now multiply that with the num is this time 2, so 60 into 2 will happen now. So now 60 into 2 will happen in this time, 60 into 2, that is 120. Now decrement cx, it becomes 1. So is it 0? No, go back up, decrement num, it becomes 1. So multiply 1 with whatever is in ax, that is this statement will do that. Okay, then decrement cx again, now cx becomes 0. Now jump not 0, but it is 0, so it will come back. So it will come back, so our answer will be in the ax, because mul is multiplying the num, which I am decrementing again and again into the ax register. Okay, and you can have a shortcut here, you can use cx instead of num, because anytime you have to decrement cx and all, right? Or you can use the num as well, because in the num, if it becomes 0, you can come back. So you can do that way also, or you can do this way, right? So after it comes back, my answer is in the ax, because mul num is multiplying num first 4. First time num was 4, because I decremented the num. First time the num was 4, so multiply 4 with the ax register, which was having 5 in it, 5 4 20, so ax register is having 20 in it. So next time decrement num, it becomes 3, so multiply 3 with 20. Okay, then answer will be in ax. Next time decrement again the num, it becomes 2, so 2 into whatever is in the ax. At that time it was 60 in the ax, 60 into 2, that is 120. And now in the num becomes 1, decrement num becomes 1, so 120 into 1 is 120. And in the meantime cx hits 0, it gets out of it. So with 120 in the ax register, okay, now 120 in the ax register, it will return to where from it was called here. So at that moment, what I do is I put ax into the num, because whatever the ax was, I put back into the variable num. Okay, so the answer will be in the num, or you could have another variable, maybe the result, or I call it a fact, dw. Okay, dw question mark, and I may put into the fact. I may put this ax into the result into the fact variable. Okay, I may have, because this is a fact, so I should use maybe I call it result, result. Okay, now emulate it. Just try to see what will happen here. Let me put it in the perspective. Okay, now what I'm doing here is I go single step. First, it will get the address of the data register AX into this. Okay, then if I do again single step, now where is it? It put up into the AX single step again. Now 5 goes into the AX. Now it is actually this. Here is the instruction. Now after that is move num into CX. So whatever is the num, single step, so 5 goes, because in the num was 5, that goes into the AX. After that it goes to CX. Now decrement CX. Now CX becomes 4. Okay, CX becomes 4. Now multiply the num with the AX, so it gets into it. So it's a hexadecimal 14. Okay, because it's a hex in hex. Then go for the single step again. Is CX 0? No, it is not. It's 3. Go back to again and decrement the num. Okay, so num will become one lesser. Multiply num with this, so it goes on and goes on until the CX hits 0. When the CX hits 0, it finishes. Okay, now CX is 0. It will not jump. It will get out of it and go where? It will go to the main where from it was called. It will return to where it was called. It was called here, and here it will do what? It will put AX into the result, do single step, and now in a result we will have an answer. So if we see here the variables, okay, if we see here the variables by pressing the var here, and it is a hexadecimal, maybe I use the integers. So in the result I got 120. I want the integers, okay, whatever that is. Now num has become 1. In the end num becomes 1. Okay, but the result is 120. That is in the answer. Now you can print this 120 using the printdl method and all procedure. So this is how we do the factorial program. Okay, where we have to decrement 1 and multiply it itself. It's very simple. You can, if you are not getting it properly, you can repeatedly see it and try to see what is in the AX, what is in the registers, and what happens, how it jumps back in the factorial program, how it jumps back, because CX is not 0, so it's gonna jump not 0. So it's a conditional jump getting on here, and it will finish the job and print the answer for us. Hope you got it. Just watch it, use your copy and pen, and put up all other things like scanning from the keyboard and printing the answers. Try those things. You should be able to do that. Okay, then see you next time. Until then, ma salama.